Good morning, my fabulous chemistry minions. Video number 3. This is going to be on the octet rule, and we're going to figure out why atoms react to form bonds. And then we are going to explain the energy needed to make or break bonds. Okay? So, first piece of information is the nuts and bolts of the entire unit. Valence electrons are either gained or lost to complete this atom's outer shell. Okay, they all want 8, and we're going to find that out in a second. How they gain or lose electrons determines what kind of bonding it is. So transfer of electrons is ionic bonding, sharing of electrons is covalent bonding, and a mobile sea of electrons is metallic bonding. Okay, we're going to need to know all 3 of those terms. Okay, and basically what happens is everybody wants to be a noble gas. Everybody wants 8 valence electrons, except for hydrogen, helium can only hold 2. They have a duet instead of an octet. Otherwise, 8 is great, and we're always looking for 8 to be satisfied. Okay? Now, it says here when a chemical bond forms, energy is released, and compounds formed are more stable. This is true, and this is true for all kinds of bonding. Making bonds releases energy, making it more stable. We need to know the bigger idea here is that, stable is lower energy. So we always need to lose energy to become more stable. Okay. And then to break a bond, independent of what kind of bonding, we have to add energy to literally break that bond. The energy that I add gets stored in the pieces that I create, and these are now more unstable because they're at a higher energy. Okay, energy flow. Okay, now exactly ionic bonding, what's going on? Again, complete transfer of electrons from a metal to a non-metal. Those are highlighted for a reason. They're what we're going to use to be able to determine from a chemical formula, is it ionic or is it covalent? If it's a metal and a non-metal together, it is ionic. Okay, and then I know from that the electrons were completely transferred, and I can kind of use the definitions to compound what's going on. So we need to pay very, very careful attention to all of this information because it's said to you with as few words as possible, but every word kind of matters. Okay, so pay very close attention. The plus and the minus ions that are formed when I transfer electrons then stick together like magnets, and here are some examples. I don't need you to draw the entire picture, but you do need to draw something here to show me that you understand that Na is losing an electron, it's going to Cl, and then Na becomes Na plus, and then Cl becomes Cl minus, and then what happens is a positive and negative stick together like magnets. Okay, but this picture that I put up is really excellent at showing you what's happening and why it's happening. This electron from sodium in its third valence shell is jumping over to there, and you can see it. There it is. So it's been completely transferred from one to another. This is like I drop $1, you pick up $1. Okay? And then the next one, CaCl2, Ca has 2 valence electrons, so he's going to drop $2. Okay? But as you see in this picture, chlorine can only has room for 1. So when the question comes up to you, well, why do you need 2 chlorine atoms to bond with a Ca? Well, because Ca has those 2 valence electrons to give, and each chlorine can only take 1. So this doesn't happen to you very often, but if I drop $2 and the rule is you're only allowed to pick up 1, I know that don't make no sense to you, but you only got room for 1. You pick up 1, and then somebody else has to come along and pick up the other one. Okay? So that's what's going on with CaCl2. I do need you to take a minute to draw something in the space that I provided you so you understand that concept. Complete transfer of electrons, ionic bonding. Okay, I'm moving on to covalent bonding. Right off the bat, these are 2 nonmetals, 2 or more nonmetals sharing now valence electrons with one another. And these pictures are going to be slightly different to show you the difference. Where one was a complete transfer of electrons, these guys now are going to kind of overlap. And we're going to find that when we draw these guys, this is what becomes the bond. That is 1 electron from one hydrogen, 1 electron from a different hydrogen. And they're labeled differently pictorially until you put them together. Then we're going to learn to just draw that as a bond and not even draw the electrons anymore. Okay. Again, with the HCl, Notice the X is coming from hydrogen and the Cl has 7 valence electrons, but when this happens, there's now actually 8 valence electrons around Cl. If he borrows hydrogens, because they share, he'll have 8. And then hydrogen needs to borrow 1 back, so he has his 2, and then he's all set. And that meets the criteria of our previous notes from the other page. And then here is water. Oxygen has 6 valence electrons, so 2 hydrogens can come in, and this is where those bonds are going to form. But we're going to learn that when we see this, drawing it the original way, we're going to end up changing that to just drawing this as a bond. Okay? Whenever I see 2 electrons from 2 different atoms, we're going to learn to draw that as a bond. Okay? Now, if both ionic and covalent bond are present, you are looking for a polyatomic ion. This is a classic Regents question. Okay? The bonding within the polyatomic is usually almost always covalent. They're always non-metals, but they've collectively lost or gained an electron. Okay? And then the bonding between the polyatomic ion and a metal is where the ionic bonding happens. So both are present, and here is a picture and how we draw it. Notice carbon, oxygen, oxygen, oxygen is CO3, which is carbonate, and then this is calcium carbonate. This is where the ionic bond is happening between these 2 guys, but this is all covalent bonding. So both are present when there is a polyatomic ion present. That's the trick. If you see when are both kinds of bonding present, it's when you see a polyatomic. So you're looking for a polyatomic ion in your answer choices. Okay. Here's another one. This is Mg magnesium phosphate, PO4, and this is just a picture I found of what it would look like if we were to draw it. I don't think I'm going to make you draw too many that have polyatomic ions in it. What I need you to do is know that when there is a polyatomic ion, both kinds of bonding are present. That's the key. Okay. Now, metallic bonding, this is more than one metal. Okay. And it can be the same metal even, but the metals exist as this mobile C, and this is how electrons happen. And this picture helps me convey the message to you. Each atom loses its valence electron readily, contributing to that C, because they're thinking to themselves, well, if I lose mine, somebody else has lost theirs, and there's always going to be an electron around me in this sea or cloud of electrons. And this is what happens. They're just all over the place. And now electrons can flow through the metal, and that's why it conducts electricity. It's kind of neat. A swarm of delocalized electrons. We call that a mobile C. Okay, and with that, we've just gotten through the basics of bonding, but you need to understand every little bit that we just did so we can go into detail now. We need to be able to name each kind of bonding, covalent, ionic. We need to draw them, and we need to know their properties, their physical properties. That'll be the lab. All right.